Hello students, welcome to Saurav Sir's classes. This video is double integration part 3 and we will start this video with properties of double integrals. That is, what are the different properties that the double integrals satisfies. Now the first one is double integral over region R f of xy plus g of xy. So we have two functions f and g, and both are the functions of two variables x and y. So this dA, this is equals to double integration over region R f of xy dA plus double integration again over region R g of xy dA. So what we are doing is that this integration of whole sum of f of xy plus g of xy, so it is equals to integration of f of xy plus integration of function g of xy. So this is the first property of double integrals. Now the next property is, the second one is double integration over region R f of xy minus g of xy. So instead of plus, here we have minus into dA. So this is equals to again double integral R f of xy into dA minus double integration R g of xy into dA. So just like addition, for subtraction the same property holds, that is the double integration of f of xy minus g of xy, it is equals to double integration of f of xy minus double integration of g of xy. So this is our next property. Now the third one is double integration over region R k into f of xy dA, where this k, it is a constant term. So this is equals to, the k will come out of the double integration, so k into double integration R f of xy into dA. So what is happening is that if there is a constant term inside the double integration, then this constant term, it can come out of the double integration. So it is the third property. So the next property is, suppose we have, that is, if this f of xy, this function f of x and y, this is less than equals to g of xy on R, then we would have this double integration over the region R f of xy dA. This would also be less than equals to double integration over region R g of xy dA. So if f of xy is less than equals to g of xy on R, then this double integration over the region R f of xy dA, this is less than equals to double integration over region R g of xy into dA. Now the next property is, that is the fifth property. So suppose we have a function f of xy which is greater than equals to 0 on R, and suppose s and if S it is a subset of R, then what we would have is that double integration over region S f of xy dA, this would be less than equals to double integration over region R f of xy dA. So suppose this is our region R and this is our region S, which is a subset of R, and if f of xy it is greater than equals to 0 on R, then we would have double integration on region S f of xy dA. This is less than equals to double integration over region R f of xy dA. Now similarly, suppose we have two regions R and S which are non-overlapping region. So we have a non-overlapping region like something like this. Here this region it is R and this one is S. So as we can see, they are non-overlapping. So if R and S are non-overlapping region, non-overlapping region, then we would have double integration over region of R union S f of xy dA. This is equals to double integration R f of xy dA plus double integration over region S into f of xy dA, where this f of xy it is greater than equals to 0 on R union S. So f of xy, this function f of xy, it is greater than equals to 0 on R union S. So we will have double integration R union S f of xy dA. This is equal to double integration R into f of xy dA plus double integration S into f of xy dA. And it is only true when this R and S, they are non-overlapping region. So only when they are non-overlapping region, then this property would hold true. So these are some of the properties of double integrals. In the next video, we will solve some of the problems based on double integral. So thank you for watching this video.